Hello, my name is Rob Reynolds. Welcome to my introductory video, and I'm going to actually talk about a prerequisite for your very first lesson because this book presumes that you have some understanding before we dive into chapter 1. So I know students generally have a hard time with factoring, so I'm going to cover factoring. You can talk to me about Maui anytime. I used to live on Maui. I used to teach on Maui. This is my wife, Rhonda, teaches at Valley High School. My son, Andrew, who just graduated from Valley High School and is going to be heading to Des Moines Area Community College Ankeny campus, engineering major. And over here we have Will, and he is going to be an Iowa State sophomore, also engineering. Again, there's pictures, proud, two boys, just finishing up. This was the beginning of his freshman year, and these are my son's senior pictures, so those are about a year old. So we're doing introductions online. If you haven't figured that out on Blackboard, please introduce yourself online so I can kind of get to know you, and other classmates can kind of get to know you as well. Make sure you know the syllabus. Some of you did not register for the correct My Math Lab. The course number, don't use this red one. Your course number for the online course is Reynolds 01955. I might have used something different on the video or something, and so some of you got some things mixed up. If you didn't do that, I'm trying to work with My Math Lab to get you into the right course. So look at the My Math Lab directions, which I've emailed to you, and look at your syllabus. Everything's posted there. But I must have had something wrong somewhere because some of you still got in the wrong course. Check out the calendar. Keep in mind everything that we do this week is due the following week on Wednesday. So everything in yellow will be due 11:59 on Wednesday. The only exception to that is if we have a test. Again, Blackboard is where you want to go and get some information, introducing yourself, and this is also where I'm going to be posting these brief, short videos, lesson videos. Make sure you ask me about My Math Lab. You should be starting your homework assignment. If you haven't, talk to me about that course code and how to sign on there. So here's your first lesson. Notice I'm going to skip all of these reviews except for the factoring lesson, and that's what this assignment's all about. So I'm going to assume that you remember how to do synthetic division, how to add, subtract, multiply, and divide rational expressions, and how to manipulate, simplify, solve roots and rational exponential functions. If those seem scary to you, it's okay. I'll teach you all those things. But again, this book assumes that you have a working knowledge. So the greatest common factor says, what can you pull out of the 2x and the 4 that's common to both and divide each term by? Well, in this case, you can divide each term by 2. And so that's what becomes the greatest common factor. The question is, what's left after you divide out of 2? And in this case, if you divide out of 2, the remaining factor is x plus 2. So you keep the GCF 2, and you divide, and what's left is x plus 2, the remaining factor. Same thing for a trinomial. Again, you divide each term by 2, and what would be left would be 2x squared divided by 2, negative 4x divided by 2, and 8 divided by 2. And if you divide every term by 2, you can see the remaining factor will be x squared minus 2x plus 4. Same thing works for variables. The GCF here is x, so I would divide each term by x. And then you should see, remember, x divided by x is a 1. Some students forget this 1 right here. So you hang on to the x, don't throw that x away. So the GCF is x, that's part of your solution, and then the remaining solution is what you get after you divide each term by x. So x squared divided by x is this first x, and then x divided by x, don't forget about the 1. And the last one you can try before I reveal it. What's the GCF? Hang on to the GCF. I believe it's 3x. If you divide each term by 3x, you tell me what's remaining in here. Something plus something. Hopefully you have the solution. I'll reveal it, and you can practice some of the extra ones as well. So greatest common factor is the first thing you always look for. Difference of two squares says we're going to slap down two sets of parentheses, and this has to be the difference of two squares. You cannot do this with the sum. So the difference of two squares says x and x are my first terms, if you know the FOIL method. 2 and 2, so we could talk about what perfect squares are. 4, 9, 16, 25. All of these are perfect squares, and you should recognize them probably up to, let's see, 169 you should know is 13 squared, 196 is 14 squared, and maybe even 225. Sorry, my cursor is not working properly, so I'm trying to use my mouse on this lesson. So x plus 2, x minus 2 is how you factor the difference of two squares. Same thing here, except factoring the, oh, let me go back. You cannot, this is a common mistake, if I give you x squared plus 4, don't try to factor this. Some students think that this is x plus 2, x plus 2, and it's simply not true. If you were to FOIL this back together, you would not get the original x squared plus 4. If you FOIL this back together, you actually get an outer and an inner term appearing. The outer term is 2x, the inner term is 2x, which creates a positive 4x. So I'm just proving to you that this is not equivalent. So you do not want to factor the sum. You can only factor the difference of two squares. So this is a not true statement. Don't do this. Don't factor the sum. So you can factor the difference of cubes. This is a nice little rule that the book assumes that you remember. The rule for x cubed minus y cubed is write down the bases of what's being cubed. You first square the first. You take the product. You square the last. And the rule says first you keep the sign. Well, the sign started in negative, so keep it. Then you change it. And the last one's always plus. I'll write those notes down for you here. So again, we write down the bases, square the first, take the product, square the last. First you keep it, then you change it. Last one's always plus. We'll try it again. Not only could you do it with the difference for cubes, you can do sums as well. So again, the base here is x. That's what's being cubed. And then you need to know perfect cubes. So 1 times 1 times 1, 1 is a perfect cube. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4, or 4 cubed, is 64. And 5 cubed is 125. So know your perfect squares up to 15 times 15. Know your perfect cubes up to 5s. So 8 is a perfect cube. The base is 3, because you can write this as x cubed plus 2 cubed. So that's what I mean by the base. So you write down the bases of what's being cubed. Again, the rule stated on this previous slide, you square the first. So the first term is x. You take the product, which is 3x. You square the last. And once again, you keep it. This time it's a plus. Then you change it. Last one's always plus. So there's factored forms of sums and differences of cubes. This means factor completely. So I always like for you to factor some mores. Ha ha, little joke here. So if you think this is the difference of two squares, because 16 is not a perfect cube, you get x squared plus 4 and x squared minus 4. And the trick here is you cannot factor x squared plus 4. But you can factor some more, because x squared minus 4 is the difference of two squares. So you're not done. Keep factoring. We keep this x squared plus 4 the same. Sorry, my handwriting looks like a third grader. But this is the difference of two squares, x plus 2 and x minus 2. I'll try to get my tablet next time so I can write a little bit neater next time. There's factored form for this problem. Another form of factoring is trinomials. And when you factor a trinomial, you have to read the signs. This says signs are going to be alike, and you're also looking for factors that add up to the middle term. So this last sign tells me two things. I need factors of 9 that add up to 6, the middle term, and signs are going to be alike. What signs? Well, the signs that are in these parentheses. This first sign tells me what they both are. So I know signs are alike, but I don't know if they're both pluses or they're both minuses until I look at the first sign. So this first sign says that they both are pluses. So learn how to read your signs. Ha ha. So I'll put a plus here and a plus here because the last sign says signs are alike, and this says that they're both plus. I need factors of 9 that add up to 6. Of course, we know that to be 3 and 3, and we'll try an x and an x. There's all sorts of ways to factor by cubes. So here's the rule again. If the last sign is a plus, we're going to say signs are alike. and we're looking for things that add up to. So two things, alike and add. So in this case, we're looking for factors of 6 that add up to 5. So should I use 1 and 6 or 2 and 3? Well, 2 and 3 adds up to 5. So let's slap those down. Signs are going to be alike, and they're both who? Well, this says that they're both pluses. So in this example, I'll say x plus 2 and x plus 2. In the next example, which is very similar, I'm still looking for factors of 6 that add up to 5, but this time signs are alike and they're both minuses. So factors of 6 that add up to 5 are still 2 and 3. You can go 3 and 2 if you like. It doesn't matter the order, because 4 times 5 is the same thing as 5 times 4. But just make sure that the signs are alike. And again, this tells me that they both are negatives. Down here, a little bit different. This time it says signs are going to be different. So we look at the last sign first again, but this says signs are going to be different. And I'm not looking for things that add up to the middle term. Now I'm looking for things that differ by. So in this case, I'm looking for factors of 6 that differ by 5. So this time, again, my factors of 6 are 1 and 6 or 2 and 3, but I think this time I'm going to use 1 and 6 because that differs by 5. Again, if you want to go 6 and 1, you can. So signs are different, and the larger term here is positive. So I'm going to say the larger term are my outer terms. The smaller, or the lesser of the terms, is my inner terms. So how does that differ from this last example? Well, again, I need factors of 6. This says that differ by 5. Again, I'm going to use 1 and 6. If you want to do 6 and 1, you may. But factors of 6 that differ by 5 are 1 and 6, and signs are going to be different. Well, this tells me what the larger term is. So the first sign doesn't. Up here, they told me what they both are, because signs were alike. So here they both were pluses or both were minuses. Down here, this sign now tells me the larger, and be careful, it's not the larger number. It's actually the larger term. And I'm doing the FOIL method, so you want to think about outer terms and inner terms. So look down here. My outer terms is 6x, where my inner terms is only 1x. And it says the larger has to be negative. So let's make the 6x negative, forcing this guy right here to be my positive. Several ways to factor. If you know a different method, please do so. Sometimes you factor by grouping, factor by the rainbow method. So let's try it. Factors of 10 that add up to 7 are not 1 and 10, because that adds up to 11. So factors of 10 are 2 and 5. Signs are going to be who? Alike. They're both positive. So x plus 2 and x plus 5. You can FOIL that back together and make sure that it actually works. Some people just like to do trial and error. So what? Signs are alike. They're both negative. Factors of 8 that add up to 6 are what? Okay, good. 4 and 2. And we know signs are alike. They're both negative. So x minus 4, x minus 2. This time it says signs are going to be different, and I need factors that differ by only 1. So factors of 12 are who? If you don't know them, list them out here. 1 and 12, nope, that differs by 11. 2 and 6 differs by 4. Keep going, there you go. 3 and 4 differ by 1. So let's put down a 3 and a 4. Signs are going to be different. Larger term is negative. Remember, go for the term. Outer terms or inner terms. Larger term is negative. This is positive. We've already talked about this, but again, don't try to factor this. This is the sum. You may not factor this to x plus 3, x minus 3. That's a trick. Just write the word prime. For the last example, we have a leading coefficient. So I'm going to find factors of 2, the first term and the last term. In this case, that differ by only 1. So the factors of 2 are 1 and 2. The factors of 6 are 1 and 6, 2 and 3. And I'm looking for factors of the first term that can match up with the last term, such as 2 and 2, it gives me 4. The forcing the 1, not with the 1 or the 1 with the 6. You have to go 1 with the 3, which is great because now we have 4 and 3 that differ by 1. So the final solution here is I'm going to use the FOIL method backwards to factor. My first terms are 1x and 2x. My outer terms are listed right here, 1 and 3. The inner terms are 2 and 2. Signs are different. The larger term, not the larger number, 4x is the largest term, make that negative, forcing this to be positive. I hope that helps factoring. If you have questions factoring by grouping, email me. Hope this helps. Have a good day. Bye.